So we're going to begin now by looking at exponentials. And a lot of these are not difficult at all to look at. And some of them you can just kind of see just by glancing at it what the answer will be. So here's one that I want you to solve. Now what's unique about these is notice that the x is to a power now. So instead of it being down below, it's to a power. This one actually comes out to be a whole number, but sometimes they may come out to be a fraction. So answer me this question. 2 raised to what power is 8? Well, 2, when we square it, what's 2 squared? Actually, let's make that 16 so it comes out right. Sorry about that. Make that 16. I did it wrong in my head. Okay, when we have 2. Okay, well, 2 squared, what's 2 squared? 2 squared is 4, right? So we can see it. What about 2 cubed? 2 cubed, I read it wrong. I had it right the first time. I made it up and I wasn't thinking in my mind when I did that. But 2 cubed is 8, right? So what power of x do you think is going to make this work? In this case, x would be what? 3. And we got that just by looking at it. Right? Because 2 cubed is 8. How else could you have done it? Well, let's say I couldn't just see it, and I was going to try and work it out. When we will work out something like this, we already know what the answer should be. We know that that answer is going to be 3. But let's say we couldn't just look at it and tell, because it might have come out to be a fractional power, or we just couldn't really work with it. Well, what we need to do is we need to look at it and we need to convert. Now, we want them to be the same bases. And the bases are the numbers down below. Or the bases must be the same. So the bases must be the same. So that's going to be our goal. We have to make sure that these bases are the same. So when we look at this, we want to raise 2 to some power to make it 8. And we know in this case, 2 cubed is 8, right? So 2 cubed is 8, and now look at them. So we know that 2 cubed is 8. Are the bases the same? Yes, the bases are the same, so the exponents have to be the same. Because we know that 2 cubed is 8. And so if the bases are the same, then the exponents are the same. So x must equal now 3, right? We did it first just by looking at it and did it kind of mentally, because we know that 2 cubed was 8. But if you can't just see it, like the next one, you're not going to be able to just look at it and see. You're going to have to transform it. And you always try to take the smaller one and figure out what it needs to be the larger one. So let's do another one. So let's try and solve this one. So I want you to try and solve this one. Well, we want the bases to be the same. And this one, unlike the last one, we can't just look at it, right? It's too difficult to just look at it and see. So what we want to do is we want to take the 4 and we want to raise it to some power to get 16. Well, 4 raised to what power is 16? 4 squared, right? Because, yep, 4 to the first is 4. 4 squared is 16. So we're squaring or taking it to the power. We just run through our powers until we find it. Now we can rewrite this. So now we have 4 to the 3x minus 1 power equals 4 squared, right? Now, once the numbers down below, the bases, once the bases are the same, then the exponents are the same. So since the bases are the same, then the exponents must be the same. So that tells me then that these have to be the same, and we can solve it now. So once the bases are the same, the exponents are the same. So what does our equation now look like? Well, it looks like now 3x minus 1 equals 2, right? And now we can solve this just by adding 1 to each side. So 3x now equals 4, and we'll divide by our 3. And now we have our value of x, which is 4/3. Let's try another one.
So that's going to be our answer.
Yep. We just find the value of x. That's what we're trying to do, is we're just simply trying to find the value of x here. So the first thing we always try and do is we try to figure out what number we raise the smaller number to make it the larger one. And all we have to do is we just check. We just use our calculator and we use the caret key to check on this. So we're looking at 5. So 5 squared is 25. That doesn't work. But what about 5 cubed? 5 cubed is what? 125. So what's our power now going to be? 3. So now we can rewrite this as 5 to the 4x minus 1 power. And that equals now 5 cubed, doesn't it? Are the bases the same? Yes. Since the bases are the same, then the exponents must be the same. And we can solve this. So we add 1 to each side. And now we've got 4x equals 4. Divide by our 4. And so our answer is now x equals what? X equals 1. You can have x's on both sides. All right, so let's work with this one. Again, same directions. We want to solve it. So we're going to try and solve this now. What do we know? Well, we look at the smaller number. What's our smaller number? 7. We need to raise it to some power to get to 343. All we do is we use our calculator. So 7 squared is 49. Well, what about 7 to the 3rd? And we just keep trying numbers till we find it. And it's usually pretty small. Well, 7 cubed is what? 343. Now, when we rewrite it, that 3 is going to have to be multiplied through. So we have a 7 to the 3x minus 1 power. That stays the same. And that equals now 7 cubed. And we're going to have to multiply that 3 by the 2x plus 7, just like that. So you're going to have to use parentheses there. Is everyone okay with that so far? So they're not really that difficult to work through. So now, are the bases the same? Yes. So that means the exponents must be the same. So 3x minus 1 now equals 3 times 2x plus 7. Distribute that 3 through. And that's 6x. And 7 times 3 is 21. On the other side is a 3x minus 1. So move the 6x over. Add the 1. And now we've got minus 3x equals 22. Divide by your negative 3. And so x now equals a minus 22 over 3. And that's it. How about fractions? Well, fractions, we're going to have to remember how to use the negative exponent rule. Now remember, for our negative exponent rule, if we have some number a to the negative nth power, well, that's the same thing as 1 over a to the nth power, or vice versa. What we want to do on these is whenever we have a fraction, we're going to have to use our negative exponent rule. We're going to have to rewrite it as a whole number. So we're going to take these fractions and we're going to rewrite them. So let's work with another pretty easy one to handle here. So the first thing we're going to do is we're going to get rid of that fraction. Now, you can take the 81 and you could make it into a fraction and then get them done that way. I think, though, it's going to be easier if we just rewrite it without the fraction. So if we have 1/3, all right, 1/3 is the same as 3 to the negative first power. So we can rewrite that as 3 to the negative 1. Is everyone okay with that so far? So we just rewrote it. Now we'll just so we don't make a mistake with these later steps, I'm going to go ahead and distribute that negative 1 through, and then we're going to see what we've got. So I'm going to go ahead and distribute that negative 1 through, and that's going to make it a minus 5x plus 1 equals 81. And now we should kind of know what to do. Because now we've done enough of these that we can now take that 3 and raise it to some power to get 81. Can someone tell me what number I would use here? What number is going to go in that box there? 4. Right? We just used our powers and we kept working with it until we saw it. So that means now that 3 to the minus 5x plus 1 equals 3 to the 4th power. And what do we now know? Well, we now know that these are the same for the bases, right? And if the bases are the same, then what do we know about the exponents? They also have to be the same. So that means that these are going to be equal here, and we can quickly and easily solve it. So now it's a minus 5x plus 1 equals 4. We'll move that 1 over. So minus 5x equals now positive 3. We'll divide by our negative 5. And that leaves us now with x equals a negative 3/5. And that's it. There's your answer. Next, we're going to talk about roots and how we can transform roots into a fractional power. And we kind of did this a little bit before break. So we're going to learn now how to transform a root, roots to fractional powers. So the nth root of a would be a to the 1 over n power. So if I had, let's say, the 4th root of a, then that would be the a to the 1/4 power. If I had the 7th root of 3, well, that would be the same thing as 3 to the 1/7 power. And in some cases, you may have to adjust both sides to where they're both going to have the same basis again. So let's do a couple of these. I'll just make this one to a higher power. So let's say I gave you this one. We want the 4th root of 3 equals 243 to the x minus 5 power. First thing we need to do whenever we see these roots is we need to rewrite it so that it's in that base of 3. So I can rewrite this as now 3 to the 1/4 power. So that's the first thing I did. That way we can see what our common base is. And now we can just work it through with our calculator to find the power that we need. And we know we've got to raise 3 to some power to make it 243. So can someone tell me what number is going to go in the box here? Does anyone know what number is going to go in the box here? 5. Okay, so 5 is going to go in the box here. So then that's 3 to the 1/4 power, because we rewrote that with the fractional power. And that equals now 3 to the 5, now use parentheses, to the x minus 5 power. So that 5 has to go in front of whatever's already there. Now we can easily solve this because the exponents are the same. Sorry, the bases are the same. So now the exponents have to be the same. So now we've got 1/4 equals 5 times x minus 5 power, 5 times x minus 5. So we're going to distribute that 5 through. So that's 5x minus 25 equals 1/4. Clear out our fractions, so multiply everything by a 4 just to get rid of those. So that'll clear out our fractions here. And that's going to now leave you with 1 equals 5 times 4, that's a 20x. 4 times that negative 25, well, that's going to make it a minus 100, isn't it? Add that 100 over. So 20x now equals 101. Divide by your 20. And now we have x is going to equal 101 over 20. sometimes you may have to convert both numbers to a common base. So in this case, we're actually going to have to convert both sides. So the first thing I'm going to do is I want to get rid of that root. Now there's no index, meaning no number in front. So if there's no index, that's a square root. So we can write this to the half power. Is everyone okay with that? So that's the first thing I did, was I just simply rewrote that to the half power. Now, here's a little bit different take on this one. If I start working with 16, I can't raise 16 to any power to make it a 32. Because 16 squared, if I work with 16 squared, well, 16 squared, right, is 256. So it's automatically too large. We need to get these into a common base. Now, what I do know is I do know that 16 is an even number. It has a base of 2 in it. So 16 is 2 to the 4th power. Now, if that's 2 to the 4th power, let's see if I can get 32 also to have a base of 2. So see if we can figure out the other one. Once you find one of them, you can get the other one. So 2 to what power makes it 32? If you use a calculator, 2 to the 5th power, isn't it? Or is it 6? Let's see. Yep, because 2 to the 5th power is 32. Now look at what we've got. Now we've got something that we can work with. So this 16, what does it need to transform into? 2 to the 4th power. So there's that piece. What about this 32? What does it need to transform into? 2 to the 5th power, but don't forget the half is already there. Is everyone okay with what I did here? Because we want common bases. So it might be a 7. It might be a base of 5. It might be a base of 4. But you need to figure out what bases are in common and get them to have the same basis. That's what we need to do. So we always try to get those bases to be the same, so then that forces the exponents to be the same. And so now what do we know? Well, let's go ahead and clean this up a bit for you before I move on here. Okay, 5 times 4 is 20. So we have, on the left-hand side, we have 2 to the 20x power, when I clean that up. And that's going to equal 2, distributing that 5 to the 5/2 power. Now the bases are the same. So if the bases are the same, then the exponents have to be the same. So that means 20x equals 5 over 2. You can cross multiply, or you can just multiply it all by 2. Either way, I'll just multiply it by 2. And that gives you now 40x equals 5, right, because those clear out. Divide by your 40. And now we know x is going to be what? X is 8. 1/8, sorry about that. I reduced there. So does everyone kind of see how that's working? What we need is a common base. So we have to make sure that we have a common base. We can also work somewhere where we do the opposite, where we have to figure out the exponent. We know the exponent, we have to get the bases to be the same. So we're going to have to figure out what base we use to make the exponent right. And we'll start off with a really, really easy one here. So this one's not going to be bad to work with at all. We need to now find the base, because 3 is now a base. Now the same rule is going to apply. A moment ago, we had to make sure that the bases were the same, right? Now we need to make sure the exponents are the same. So now we kind of do the opposite. What number raised to the third power is going to make it 27? Can someone tell me? So what number raised to the third power? Well, let's try the powers, our numbers here. 1 cubed. 1 cubed doesn't work because that's 1. 2 cubed is 8, right? But what about 3? Yep, 3 cubed is 27. So that means this is 3. Now when I rewrite these, what do we now know? Now we know that the exponents are the same. So then the bases must be the same. So that means then that x must equal what? 3. Let's try another one. Let's use a 256 here. So when we look at this, we need to figure out where our x is at. And in this case, our x is down as a base. So what do we need to find here? We need to find some number that when we raise it to the 4th power gives us 256, right? Because that's what we want. We want this number instead of the exponent. And we just use our calculator and we check numbers. And we'll just start with 2. Okay, 2 to the 4th power, 16. Not going to work. 3 to the 4th power is what? 81. Doesn't work. What about 4 to the 4th power? 4 to the 4th power is 256. And isn't that what we need? Yep. So now we know 2x minus 1 to the 4th power equals now 4 to the 4th power. And what do we know from here? Well, from here, we know that the exponents are the same, right? So the bases must be the same. So that means these two must be the same. So what's our equation now look like? It looks like 2x minus 1 equals 4. So we'll add our 1. So 2x equals 5. We'll divide by our 2. And so x now equals 5 halves. That's it. Okay, let's now look at a fractional power. Okay, let me come up with a good one here. I'm going to come up with a number we haven't used in a while. Okay, how about A to the 3/4 power equals 5/12. And this is going to be very, very similar to question 3 in your homework. So it's almost identical, just different numbers. So the first thing we need to do is we need to deal with the numerator. And once we get the numerator, then we'll deal with the denominator from there. So our numerator is a 3. So what number raised to the 3rd power is 5/12? Can someone find that number for me? What number raised to the 3rd power is 5/12? And I'll give you a moment to find it. Shouldn't take you long, though. Just check the numbers, starting at 1 or 2, wherever you want to start at. You'll find it pretty quickly. I can tell you it's under 10. Okay, 8. So that means 8 to the 3rd power is 5 cubed. So we have that. Now, we then need to figure out how to handle, since the numerators are the same, we need to figure out how to handle that 4 down below. Now, notice the 4 is down below. So I have to make this a fraction to make it the same as that. So how would I handle that? Well, I need to make sure that I get that fraction below. Okay, and so how do I handle that? Well, I'm going to have to rewrite this so it comes out to be that 3/4. So we need to look at 8, because that's our common number here, raised to the 4th power. And what's 8 raised to the 4th power? Because that 4 is down below. 8 raised to the 4th power is 40/96. So now that tells me, because we had to take it to the 4th power, because that's down below, that tells me that 40/96 to the 3/4 power is going to equal A to the 3/4 power, because we had to make this a fraction, and by making it a fraction on the top, you have to increase the power on the side. So this is A to the 3/4 power. So where we began was we looked at our numerator, and we figured out 5/12 raised to is going to equal 3, or some number raised to the 3rd power. We found that to be that 8. Okay, so we rewrote that. And then we still need to deal with that fraction. So that means we had to base cube it to make this work. Or, sorry, not cube it, to take it to the 4th power, because it has to be the same. Now, the bases are the same. Or, sorry, the exponents are the same. So the bases must be the same. So A is now going to be 40/96. Because we have to make sure if we make this a fraction, that's going to increase that base. That should now let you finish some of the new homework. And I have also your take-home and practice finals for you to start working on. So I'm going to talk about our assignments, and we'll see what we can work through. So what can we do for our homework? Well, our homework now is you should be able to do the variation problems. You should be able to do them all. So you'll be able to do all the variation and application problems. And then the log problems and exponentials, you should be able to do 1 through 5. We'll talk about logarithms next class period. Before you leave, though, let me go ahead now and give you your practice final and take-home final. And I put the take-home final actually in front so you remember to do it. The practice one's on the back with an answer key. Next week, or actually probably give it to you on Wednesday, if I have time to get it done, I'm going to work out the practice one and show you how I did all the steps. So next week, at the latest, probably on Wednesday, I'll try to have it done by next Wednesday, I'm going to work through the practice final. I'll work out each and every single one of them, all 40 of them, so you'll see how I did every step. But I'll try to give that to you on Wednesday, at the very latest on Monday. So that's going to be your assignments now.